And welcome everybody to the Daily Space Weather. Right now we're looking at the northeasterly quadrant of the closest star to see a new sunspot, possibly 2814. Some filaments up there. The possibility for Earth vicinity coronal mass ejections is still there. By the way, I'm your host Dan, aka smAsho. We'll also be talking about a talcum powder comet, double quasars, and another gamma ray source. Here are the magnetic fields associated with this possible new sunspot. And it doesn't look particularly strong here. It looks like it's actually already begun to degrade. Kind of near my pointer right there. And we'll show you more imagery of that later in the video. First, a 171 angstroms full disk view along with the colorized magnetogram. And if you want to look up this data yourself, go to the SDO page, click on data, and this is in the AIA/HMI browse data. Again, this is the 171 angstroms and colorized magnetogram. Here's another close-up of the northeastern quadrant in 304 angstroms. And we've got some even more extreme close-ups for the end of the video for you. Next, a chart of the solar system. Keep in mind, folks, this is not to scale. Here's where stuff is right now. And there's where things will be in a week on April 14th. Here's a star chart. And you may be freaking out because Saturn is in Capricorn. I don't know why, but in any case, if you're up before dawn, you may see Saturn rising ahead of the sun if you've got a clear sky and a view of the ecliptic. Also, the moon and Jupiter rising in tandem right now. And I like to use in-the-sky.org. You can create your own star chart there by putting in your location. The radio flux of the 2800 megahertz variety, otherwise known as the 10.7 centimeter radio flux, now at 74 solar flux units. Here's the 1 year chart, this black line up top. To put that in context, the red line on the bottom is the sunspot number. You can find this chart at solon.info. We don't see any NOAA forecasts for any geomagnetic unrest, but we do see an uptick in the solar wind. We'll get to it momentarily. First, volcanoes. Fagradalsfjall is this cinder cone back here, which is slowly turning into a shield volcano. You can see it's building up the crater valley here. And we've seen another fissure open up, which has prompted another live camera. This is actually live footage from the moment we made the feed. And check it out, Pacaya. Pacaya, the Guatemalan volcano, has had an uptick in its activity. Here is some footage from Pacaya, the Guatemalan volcano. Come on, Twitter video. There we go. I would make it full screen, folks, but it's not working. So there's Pacaya. Looks like Pacaya is creating some new real estate as well. And not all forest fires are caused by mankind, folks. It's the shock front of lava. And let's go to the list. Abico is on it. 7,000-foot ash plume at Abico. Sakurajima, 9,000-foot ash plume as it explodes. That's an uptick at Sakurajima. Sinabung, flight level 140. It's a 14,000-foot ash plume over the Indonesian volcano. Dukono exploding as well. Flight level 070. It's a 7,000-foot ash plume. So Pacaya actually had a lava fountaining episode known as a paroxysm. It produced a 12,000-foot plume of ash. It dropped lava bombs and dense ash plumes, and explosive effusive eruptions have emerged. Sangay in Ecuador, effusive explosive eruptions happening there as well as a lava flow and some glowing rock falls. Don't be under a glowing rock fall, folks. Lava bombs are not your friend. Revenador also exploding in Ecuador. 15,000-foot ash plume there, and intermittent emissions from Sabancaya are a reminder to not pole vault the caldera, a public service message here from smAsho.com. And today's featured product is the Do Not Pole Vault the Caldera fitted scoop t-shirt in purple. If you'd like to find links to that, head to smAsho.com. You can find our social media there as well as this link right here. smAsho merch is our Redbubble shop. Check it out. Next, looking at earthquakes over the past 24. No major quakes, although we did see some deep ones, such as this 4.6 in Argentina and this 3.9 in Chile. Nothing over a 5.3 magnitude, I think, was the largest of the past 24. Let's go up the list. Here's another deep quake in Western Australia, a 4.6 at Argentina at just over 100 kilometers depth. The Kermadec region saw a couple 5 magnitude plus quakes. This 5.2 and this 5.3, quite close to each other. A deep quake at Guam, a 4.6 magnitude quake at Bosnia. Not the most common spot for a quake there. Another deep quake in western South America at a 4.4. Another 5.3 at the Kermadec Islands. And the Kermadec Trench is one of the most popular deep earthquake spots in the world. This 4.8 listed as at New Zealand is actually just west of the Kermadec Trench as well. Iraq saw a 5.3 magnitude quake. So we see a bunch of quakes here in more unlikely spots, folks, but no major quakes. And really there is an ongoing earthquake drought. Here's a 5.1 at the Philippines. That's at over 100 kilometers depth. And 2 quakes reported here from China, a 5.0 and a 4.8. Getting back to space weather data, the GOES X-ray flux showing no significant solar flares over the past 24. And we don't see any proton strikes either. No surprise there, as we haven't seen any coronal mass ejections. These are measured by the GOES 16. And check out the low readings from the GOES magnetometers here, folks. GOES magnetometer registering all the way down to 55.5 nanotesla. Some very low readings. And we're getting a weak coronal hole wind stream, it looks like, is arriving once again. We'll get to it momentarily. First, some views of the heliospheric current sheet. It's the top view ecliptic plane field plot, the first of the 3 Gong 2 data sets that we'll look at. And you can see the Earth is solidly in a South Pole-oriented current sheet. I would cite the fact that there is still a possibility for coronal mass ejections, and look for additional content coming from our channel if one should happen to occur. Next, the line of sight coronal hole plot. We don't really see any coronal holes here, not in the Earth-facing zone at least, except at the solar polar regions. Keep in mind the data is 1.5 hours old from the time we made the video. And here's the line of sight ecliptic plane field plot. It also shows you the solar magnetogram. And that blue line there is the sun's B field. That is the B field. It's essentially, it's like the BZ in the real-time solar wind data. In other words, the extent to which one or the other polar field contributes. That is, when you see this blue line right here on the equator, that means that portion of the current sheet is seeing a similar amount of north versus south pole magnetism. Down here you see more south pole magnetism, and up here you see more north pole magnetism contributing to the total field known as the BT. Hope that helps. It's the line of sight ecliptic plane field plot. The rest of it, These areas out here, these are just essentially three-dimensional magnetic field line representations of the heliospheric current sheet. It's a great graphic. KP index now up to 2 as a result of an increased solar wind density. So the KP index, folks, for you new viewers out there, is a measurement of global geomagnetism. There's the 3-day chart of that. Don't be surprised to see the KP index come up here. And we're expecting to see an uptick in the solar wind speed as this density drops off. So we're pretty close to the highs here, reaching up just over 26 protons per cubic centimeter. We're currently at about 18 protons per cubic centimeter in terms of the solar wind density. Solar wind speed 361 kilometers per second. We also did see a big shift in the BT/BZ here. Current BT is at 13, so we're seeing a strong field. We see the expansion of the scale here. If you look over on the left, you can see it's now at -15 to +15. And you're talking about nanotesla there. So strong fields and South Pole oriented fields there. That -6 for the BZ is South Pole magnetism. No surprise there. The Earth is in the South Pole current sheet. And you see this signature uptick also in the plasma temperature here, the bottom pane. And we're going to show you all 3 geospace magnetosphere movies here. You can see a bunch of plasma getting re-accelerated back into the solar wind here in the magnetotail region. These green areas, those are high velocity regions. And that is plasma being reintegrated into the interplanetary solar wind. Some very high velocity zones there in the magnetotail zone. Next, the density. The last one was, again, velocity. So here's density, and we're going to expect to see a little uptick here. This is 4 hours of data. All 3 of these panes are 4 hours of data. Keep in mind it shows you high density in dark blue and low density in white. And lastly, the pressure. And we can expect to see a minor uptick in the pressure here toward the end of the video. Again, we can expect to see the solar wind density drop off and the solar wind speed come up, as this is certainly another coronal hole wind stream striking. And we're expecting it to be short-lived. I would expect this to last less than 12 hours. And we do see some ground-based magnetic perturbations here, so we're going to show you the polar view on ground magnetic perturbations. So there's pressure, and here are ground magnetic perturbations. And you're going to see a little increase here as a result of that uptick in the solar wind density. Geospace delta B, folks, is a reference to changes in the Earth's B field. You're looking at nanotesla here, and the scale is at the bottom. It's all based on the space weather modeling framework, and it is indeed a model based on a lot of direct empirical observations. So here's the global view, and we show this daily, and since it refreshed, we're going to let it play through. We show this one daily due to the fact that the Earth is experiencing a geomagnetic excursion. The North Pole has split into 2 North Poles. The South Pole has left the Antarctic continent and is someplace south of Australia. Also, the South Atlantic anomaly has split into the South Atlantic and South African anomaly, so we keep an eye on this daily. And when I say eye on, the pun is intentional. Now, we stream a lot of videos to Twitch. It's twitch.tv/smAsho, but today, not so much. Now, we are going to live stream the cosmology segment, so we'll get to that momentarily. First, I would remind everybody to press like and subscribe if you're viewing on YouTube. Thanks to our subscribers, our friends, our foes, and our neutrals. Don't forget to check out our playlists as well. Playlists are located at youtube.com/smashomash/playlists. Thanks to our BitChute subscribers as well. Check out our 400 subscriber special over there. And welcome to today's cosmology segment. It should be quite interesting, and so we're streaming it live to Twitch. This is a portion of the daily space weather video, and if you want to see the whole content, become a patron at patreon.com/smashamash. First, double quasars. Hubble has spotted some double quasars. Now, these are located about 10 billion light years away, and double quasars are fairly rare in that quasars are galactic cores. And they're a special kind of galactic cores, some of the most active galactic nuclei, maybe second only to blazars. The poloidal jets of these galactic cores are oriented directly towards you, which is why they look so bright. And about 1 out of every 1,000 quasars are doubles. It's like looking for a needle in a haystack. And Hubble has found a couple of them in let me go back up here, in J0749 plus 2255 and J0841 plus 4825. So those are a couple examples of double quasars. And these are interesting objects to say the least. Those two that we just showed you photos of are only about 10,000 light years apart. And to put that in context, the Sun is about 26,000 light years from the Milky Way's galactic core. This article's on phys.org's Astronomy and Space section. Go have yourself a read if you want to read about double quasars. I thought it was interesting. What about you? And by the way, here's one of the double quasars you can find. This galaxy is actually NGC 6240. We've got this incredible high-resolution image here. And let's zoom in on the core of this galaxy. You can actually see the two bright spots in there, one of the many already discovered double quasars. Fantastic view of that. Again, it's galaxy NGC 6240, the new general catalog, entry number 6240. And it looks like a merging galaxy to me. What say you? How about a new gamma ray emission detected? It's from supernoval remnant G272.2-3.2, a catchy name. And this one is located at quite a great distance, folks. But in any case, we're going to show you some imagery of this area. Now, this is located pretty close to the galactic plane, so it's going to... there's going to be some limited data on this one, but we'll show you some interesting stuff regardless. And yesterday we talked about pevitrons. This is a little bit lower energy state than pevitrons, but we're looking at giga-electron volts here. So 2 to 500 giga-electron volt energy band is quite high energy. This article also from phys.org in the Astronomy and Space section. It's supernoval remnant G272.2-3.2. So go have a read on that if you like. Gamma ray emissions noted from that. And here actually it is. So this is what we're looking at here is hydrogen alpha, folks. So this is the spectra of hydrogen gas, and you can see this massive gas cloud. That's the Milky Way galaxy. And this supernoval remnant is actually on the other side of that. So we're going to pull this down, and we're going to put up the 2 mass, which is infrared light. And we're going to zoom in on this supernoval remnant. And you can see there's not really a lot to see there. This is located at a great distance. And let me see here. I think this one shows up in UV. Maybe not. How about blue light? Maybe not. How about optical? Anyway, it's a very tough to see supernoval remnant. It's not particularly exciting looking. However, since it is emitting gamma rays, it is interesting. Now, there is also some interesting features here. It does look like there may be a jet involved with this one, but without continuing to look at basically a blank part of space here. we'll just continue on. To talk about talcum powder comets. So, that right there is a Chinese baby powder factory talc pulverization talcum powder boom. Turns out that some comets, namely Comet P2016 BA14 discovered by Pan-STARRS, is covered in talcum powder. Yeah, for real. It's a burnt-out comet. What are the chances, folks? It's a burnt-out comet covered with talcum powder. Now, Johnson & Johnson is trying to mine the surface of the comet in order to cheapen their talcum powder production operation. I'm just kidding, folks. They're not really trying to mine the comet. Anyway, the fact is, the question is whether comets are covered with talcum powder from the start or if it develops over time as they burn out. The result provides us a precious clue to study the evolution of comets. Comments Dr. Takafumi Utsubo, the lead author of the research. We believe that further observations of the comet nuclei will enable us to learn more about the evolution of comets. It's a talcum powder comet, folks. What are the chances? And that's today's cosmology segment. And don't forget to share our content on your social media if you enjoy it. Don't forget to follow us on YouTube if you're viewing elsewhere. I've been your host, Dan, a.k.a. smAsho. And again, that's today's cosmology segment. Continuing on with some more daily space weather type information. The electron flux is quite low right now, and the NOAA forecast is for it to be even lower. Here's a 3-day chart of it as measured by the GOES 16. The greater than or equal to 2 mega electron volt electron flux. And here's the forecast. You can see the forecast is for even lower levels. And I would tend to agree here, as we are, once again, we're seeing a coronal hole wind stream arriving. Here's a diagram of the Van Allen belts. It's showing you altitudes of spacecraft in miles. And here's a visualization of the total electron content. We can expect this to be a little bit chaotic here, and we are indeed seeing blobs of electrons at nighttime over the equatorial region. No real surprise there. That's what we typically see during times of coronal hole wind streams. We see a more chaotic set of Van Allen belts. And I'll let that play through again. This shows you GPS errors, folks. So that's the total electron content forecast. Here's another diagram of the atmosphere. It's showing you bands of the atmosphere down there at the bottom, such as the troposphere, where all your weather occurs, the stratosphere, where most planes are incapable of flying, and most importantly, the F-ionosphere layer. Why? Because the next slide we're going to show you is the F-ionosphere layer, the portion of the atmosphere located at about 300 kilometers altitude. This is the vibrational frequencies happening in the ionosphere, and we're seeing some anomalies here. I would also remind folks that we've got two North Poles. The South Pole is someplace down here, south of Australia. And we've got two weak spots, the South Atlantic and the South African anomaly. Now that the South Atlantic anomaly has appeared to split in two also, leave us a comment. Let us know if you think the South geomagnetic pole is going to split into two as well. Or leave us a comment if perhaps you think it already has. Shout out to Mary Wright, one of our favorite viewers. So here's the latest image. This one coming in at 9:15 Universal Time. Looking fairly normal there, but we're seeing some anomalies happening in the ionosphere right now, some sudden charge ups and charge downs in unexpected locations. Now we're going to do some meteorology stuff, and right now we're looking at surface winds. So we've got some very strong surface winds here in the southern portion of the Indian Ocean, such as this high-pressure ridge here, this very lengthy straight-line wind system down here pointing toward Antarctica, as well as two low-pressure systems here, two surface lows located northwest of Australia, also a strong counterclockwise rotating low-pressure system here in the North Pacific. Here are the jet stream winds The 250 hectopascal winds, by the way, is what we show daily on this. Next, looking at the western world's jet stream scenarios. Rotate that a little more there to show a little more of the western world. There are the west's jet streams. Quite chaotic here, once again, over the North Atlantic. And we see the jet stream diverging over the eastern U.S. and then converging over the North Atlantic. Here are the surface winds for the western world. And we see a strong low here stagnating off the coast of Cape Cod, as I forecasted about 2 days ago. Next, looking at pressure cells. And here on windy.com, we'll just advance this into tomorrow. This is the GFS forecast for pressure at 1 p.m. Eastern Time tomorrow. Here's a real-time lightning map for you at lightningmaps.org. It's where I go when I hear thunder. And we've got some terrestrial lightning here. Hey, Kansas City. There's thunder rolling in Kansas City. And yes, it will show you the expected propagation of thunder. Quite an active thunderstorm there just south of Kansas City, as well as some lightning in Missouri there east of that. We also see some South Dakotan lightning kicking up right as we make the video. And the U.S. currently, the lightning hotspot of the world. Here's the U.S. Doppler radar map, and we see some strong storms here over, just about to move into Missouri. Also some in Iowa, South Dakota, Minnesota, and northern Wisconsin. Also some rain moving promptly through Pennsylvania here. It's actually taking an odd path as it's moving a bit to the south. So that rain there in eastern Pennsylvania moving southeast. Here's a view of the cloud layer, and you can see this powerful rotating low pressure system here off in the North Atlantic. About, 800 miles north of Bermuda. Here's a water vapor map. And check it out. Check out all the rotation here over Colorado. Must be caused by all the hot air propagating out of that state. Colorado spewing hot air across the whole country and indeed parts of the world. Here come our bonus features. We're going to show you the most recent data here from the El Teide ground-based solar observatory, part of the National Sunspot Observatory. And you can see these filaments up here in hydrogen alpha, 6,562.8 angstroms. Will Sunspot 2814 remain a sunspot? Will you check out our forum at smashamash.com/forum? We've got forums about cosmology, Earth and geophysics, and more. We've also got a slam poetry contest with which you can win a free month for the month of May. You can win a free month of our $3 Patreon tier. Perhaps check that out if you're a poet. Go and submit a poem to our slam poetry contest. It's all you've got to do is just simply post a poem on forum, and we've already got a winner as we only have one entry so far. The contest goes all through April. Thanks to the Smash team for viewing, leaving comments, pressing share, pressing like, etc. Thanks to the most important members of the Smash team, our patrons, and expect to see this list updated tomorrow. Thanks again, patrons. Please consider becoming a patron at patreon.com/smashamash. You'll get all kinds of earlier alerts and all kinds of other perks that nobody else is getting. Patreon.com/smashamash. Here come additional bonus features. It's the colorized magnetogram of possible Sunspot 2814. And we can see some umbra there. Pretty weak. Let's press refresh and see if we still have an umbra. We certainly had one when I was doing show prep today, so not really, folks. Barely a dark spot there. So we may see some sunspot regions forming here. I see at least 2 different zones. And there you have it in colorized magnetogram. So we could see 2 different groups forming here. Possible sunspot 2814 and 2815. Let's close things out with some more solar imagery. Here's 304 angstroms, the full disk, the full Monty. Great view of the closest star here from the SDO's 304 angstroms ionized helium UV emission spectra. How about 171 angstroms? And since we're keeping an eye on this northeasterly area, and the pun is intentional when I say ion, by the way, those fields do not look particularly strong. And here's an extreme close-up of the filaments in the northeast. The 171 angstroms view is even better than this 304. In any case, thanks for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. Don't drink it. If you do, don't drive. Seriously, don't drive. I might be out there. And no matter how much I like you, I don't like additional traffic. And we'll see you soon with more content. May that solar wind be at your back.